Hi, good afternoon, everyone. Thank you for giving me your time to talk about Radwin's products. The coverage today is discussion about our technology, which some of you are already familiar with, but also enhancements and improvements that we've made to the products and the new product offerings that we have in order to increase bandwidth and reliability for the end customers on the fixed wireless platform. Okay, so we're just going to cover some our product releases, and then also as professional services, we're offering some new products and professional services as a service as a product, and we'll talk about that. Okay, covering our technology. For those of you that are not familiar with our Radwin, we have a proprietary protocol deployment. And a lot of advanced features when you gather those together that maximizes your throughput for your customer subscriber unit at any given time dynamically, right? So we have adaptive rates for setting automatic changes in bandwidth, lots of error correction coding and requeuing. Non-disrupted transmission. We don't use Wi-Fi collision-based communication, so every millisecond is used for transmitting or receiving data. We have advanced modulation techniques that are also dynamic in order to ensure that you're getting the highest bandwidth and throughput, and then also dynamic allocation. And once we get to the physical layer, we have a new second-generation beamforming antenna, which helps you to reject noise and interference in order to maximize the received signal at both the base station from the subscriber and the subscriber from the base station. So let's talk about some of that. How our radio works is we have, looking at our architecture, it's broken into three major subsets. There's the hardware side of it, which is the Ethernet gigabit side. We have our air interface, which is our proprietary air interface, is the core of the radio. And then the RF side, we consider that as the physical module, and we're going to discuss a few things about it. On the air interface, right, to do modulation, we use orthogonal frequency division multiplexing. And what OFDM, the big advantage that you get with OFDM modulation is that it'll look at multipath signals, meaning multiple signals coming at different delay times and angles into the radio, and then be able to combine those and compare those in order to identify a phase shift, so you can get better reliability even in a multipath environment. We also implement a multi-in, multi-out antenna. So in good conditions, we can actually use that diversity of polarization in order to you do two separate channels of data to double your bandwidth to the customer. But also, if you get into a challenging environment, heavy rain, and you can drop all the way back down into diversity mode, where it's going to sum both of the polarities and send the same data over in order to increase that availability of the signal. So you're going to get high rate throughput and as you can, but as the situation deteriorates, you're going to be the last one to lose their link because of bad weather. The timing is key to everything. Because we're not using a collision-based system, right? We need to ensure that everybody is timed with hyper accuracy, meaning to the millisecond, in order to orderly transmit and receive data between the base station and the subscribers, and not get any collisions or self-interference from them. And then the physical overhead that we have and the efficiency of the second generation beamforming antenna, also it gives us a unparalleled mitigation of interference for a beamforming antenna. Couple of highlights about our proprietary air interface is that We have an advanced MCS adaptation, which is the coding sequence. How we do the coding sequence will dynamically change based on many factors: the amount of data demand that's coming across it, where is the scheduling for the subscriber, what is the current modulation technique of the subscriber. So we have an advanced adaptation for that, so we can dynamically shift. Even an intermittent interference, if it's intermittent, we can adjust for it, and then when it's gone, we can go back to maximizing the throughput of the radio. Also, in our air interface, we have a fast automatic requeue, ARQ. What that is instead of allowing, if we have a bad packet that comes across the air interface, from the subscriber to the base station, instead of allowing that bad packet to go across the network, and in the case of TCP, having the end device have to make a request all the way back across the network for that to have that packet sequence resent, or in the case of UDP, it just dropping the packet. If we sense that there is an error in a frame on the air interface, we have the mechanism to automatically request that frame be repeated after a adjustment in modulation or bandwidth, to a cleaner state, to clean it and then send it on. So we're actually passing along, and what the real world advantage of it is that you see, better efficiency of throughput on TCP connections, and then also, on UDP. Big thing on UDP is voice. Is as the durations, you're not seeing pops and clicks, or in video you're not seeing pixelization because we're automatically requeuing that frame. We also implement full quality of service. So on the layer 2, all the 802.1q, we can set your prioritization for the communications and define it onto your network, and meet those requirements in order to interface well within the layer 2 fabric of the switch network that you're connecting to. Because timing is everything, we have internal GPSs in our base stations, and we use the hub site, which is where the base station is. That's the hub site to do the synchronization. So we don't have to, add a different. You can put multiple base stations in the same physical geographic location, and they won't self-interfere because they're all timing off of the same GPS signal, independently received into their radios, and then sequence timed by their own beacons to each other. And also we have the adaptive asymmetric communications. That's one of the coolest things that I like about the Radwin radios, is that we're not beholden to the modulation being forced to be my worst client, right? I can not only independently have a different modulation to each of the subscribers that's out there. I can run that modulation independent of both directions, and with the adaptive asymmetry, I can set on top of that, right? Now I can say the percentage, based on the percentage of my traffic, I can either send more in the downstream or more in the upstream. And in many cases that we see for the internet, right, if you're doing standard internet usage, it's almost to the to 90-10 how much people are downloading versus what they're uploading to the network. But it also gives you that dynamic. If I'm doing a video network where it's completely reversed and I'm pushing all of this video information back to a core, I can set the asymmetry in the inverse and set the majority of the time of the radio asymmetrically to upload the data into the network. The bidirectional, like we were talking about, the bidirectional dynamic channel bandwidth, is that it's not just the bandwidth that's dynamic, right? It's also the modulation that we're applying to it, the quadrature amplitude modulation that we're applying to it. So at any time, if it changes or whatever the condition is, we're constantly looking to see, can we get to the highest modulation and the highest bandwidth in order to be able to push the most data through. But I'm always looking at my fallback in case I don't, and I'm doing that to every single subscriber in every single direction completely independently. That's really awesome. And how do we do that? Is that we'll also look at the dynamic bandwidth, is that it's going to look at the 20 megahertz allotments in the bandwidth. So if I have a spectrum allocation of 80 megahertz, it's going to look at it as if it was 420 megahertz blocks. It'll then say, hey, I'm looking at, get some interference and there, and do I drop down if I'm still in the 80 megahertz and I'm dropping down my modulation because I need to overcome that increase in noise, that interference, and the lower my modulation, the stronger the higher my signal is. But if I get to the point where I'm dropping down in my modulation to where it would be better to be at a lower bandwidth and a higher modulation, and in this case, you see when he gets to 16 QAM 3/4 and I'm running 338 megabits per second, if I would drop down to a modulation technique of 16 QAM 1/2, I would then, my capacity would then be 225 megabits per second. But if I went to the 40 megahertz channel and went back to without interference and went back all the way up to my 256 QAM, I could do 347 meg. So even at 338, it's going to say, hey, I can do a better rate at a lower bandwidth, so I'm going to change the bandwidth dynamically and readjust my modulation in order to assume at that next 80 millisecond cycle that I'm running the maximum throughput. And this happens continuously in both directions. Oops, right. So if we look at how also we're doing that adaptation, how do we do it? So I'm sitting there looking at whatever my current modulation is, right? So I have my green is my current modulation, but I'm always going to be peeping, which is I'm going to be looking to see what is the next highest modulation, and can I move up into that without error on my interface? Can I move up? So I'm constantly trying to move up, but in the meantime, I also have my immediate fallback. Right, so if I'm in a modulation technique, I take a burst of error on the air interface, I can immediately quick fall back to my modulation, fallback mode, and it's constantly doing that chase up and down based on changes in the environment between the subscriber and the base station. So here are some of the products that we have. A lot of you are familiar with our basic point-to-point, point-to-multipoint radios. We still have the workhorse, the Jet 750, the 2000D plus point-to-point radio. Max capacity of those on the 80 megahertz bandwidth is 750 megabits aggregate throughput. What we've done with the Jet radio is they've put two radios into a single frame and called that our Duo. Right, so now we have a 1.5 gigabits throughput. Advantages that you have with the Duo over the Jet is that you have now you have two carriers of the same footprint. So any cost that you would have associated with mounting that on a tower, you've removed that second radio mount position, so there's some cost savings there. It's also implemented an SFP interface into the Jet Duo, so now we can go higher up on the tower without having to have it any kind of a PoE injector or mounting your smart node higher up on the tower in order to get that verticality. You can drive it with fiber now and just use the Ethernet as a PoE only for power. And then getting up to for the subscriber, we're also coming out now. We're at the final point to come out with our MultiSector, and our MultiSector antenna is the same Jet Duo technology. All of its inside is the dual carriers, but out of the box, it covers a 180 degree sector, and then you can add an additional antenna, and the cabling and the ports are already for it, and actually create a dual carrier F1 reuse, 360 degree, low cost point to multi-point node. So there's some great, and we'll look at some examples for where that would be advantageous to use. We've also got a subscriber radios, the Alpha subscriber that's out there. That's now up to you can get up to a 500 megabit subscriber. and all of our subscribers, it's the same technology in that alpha form factor. So the advantage to the end customer is that I can pay for specific license speed that I think is my most common, and single rack store a alpha series radio. But then if I need to do a higher speed, a 250 meg, I can just purchase an add-on license to it in order to increase the capacity of that radio, and I'm not having to stop different flavors of subscriber units. And we still have our good old the 5000 series. If you're going to implement external antennas, we still have the connectorized version. The alpha version is a integrated antenna, and it's comparable to a little bit better, but we think of it as comparable in relation to the embedded with the turbo gate. Point-to-point radio still got the D+. It's a great workhorse radio. Works fine, lasts a long time. Two new things that we have is the IDU-S and our smart node. The smart node I really like. What it does is it gets rid of a lot of additional parts purchases and build that you have to do before you go deployment. It's a fully integrated PoE switch that has an outdoor enclosure and a slide bracket mount on it, so you could either mount it to masonry or to a pole, and then slide on and lock it, so it can be easily changed. We're using a lot of these for video surveillance networks where they're deploying video. They're putting the smart node up there as their connection to power their the cameras and the smart city devices, and then using the output of it to drive a subscriber connection back to a base station backhaul. It's about as big as a carry-on suitcase. It's light enough for a human to be able to carry up a ladder if they need to, but even out of working out of a lift truck, you're not trying to hold a big heavy Westel cabinet and slide bolts through a unistrut to try to get it connected to a pole. You put the bracket on, and then it has a keyed slot. You push it out, push the slot, slide it down, and it locks in place. It's pretty neat. And then our IDU-S, we'll talk some more about the IDU-S. That's our new layer 2 switching capable. And then we have some new urban transport equipment for train to ground. That's it's not a broad market, but there's great opportunity in it, especially for increases in funding in public transportation. There's reach out to us because we deal with those as many times as a special project, and we have a special team to help you with designing and engineering that solution with the end customer. Don't put it out of your mind that, hey, there's an opportunity in transport. And then having great hardware products is all nice and good, but you still want your networks up. You got to run your network, right? And so we have a life cycle approach to our operational support systems, and what we've done with the OSS is looked at everywhere from the beginning where I'm going to plan my network, even from the beginning where I'm going to plan my network, all the way through after my network's deployed, and then how do I manage my network and improve my existing network, and then plan in order to make addition. So it's a full circle life cycle management. Okay, so the 2020 releases, what we released here is our Jet Duo. I really like the radio. It is a high capacity dual carrier base station. Couple of the highlights on it: it runs a 2x 750 meg, 750 megabits per second on a 80 megahertz carrier. It'll do dual carrier, 5x5. It'll do 3, 5, and 5x and for IC for Canada. And we're implementing it as soon as we get FCC certification. We'll be supporting the DFS carrier bands as well. It uses the second generation beamforming antenna, and for us, we're seeing significant reductions in noisy environments to where if I'm back into doing an urban environment or an urban interface like For example, San Juan, Puerto Rico, it's a very busy environment, very noisy environment. We put the Jet Duo and saw significant increases in performance simply based on the fact it was able to have better interference rejection of and a narrower bandwidth of the propagation for the beamforming versus even our own jet radio. And when they say 25% greater interference immunity, that's actually pretty conservative. We were seeing a significant improvement. And so that's also something to think is that, go back to the Jet Duo where your noisy environment, doing something in New York City, I'm, doing a job to shoot across the East River, looking at Jet Duo, and that's a really noisy environment. Support DFS carriers, the subscriber unit dynamic carrier selection. And what that means is that if I have subscribers on one carrier because they're on the same sector and it's the same air interface, for the two is that if I have a problem or interference on one of that subscribers, right, because it might be subscriber specific, that subscriber can be dynamically shifted to the other band, which for DFS that's going to be a huge improvement in being able to use the DFS bands in order to provide reliable, consistent broadband service versus, a best effort where they know that they're going to get occasional interruptions. And then because it's the dual carrier on the back end, we have 64 subscribers on the time slots for a single carrier. We're going to support up to 128 subscribers per sector on that. Thing I was talking about with San Juan, where the beamforming, right, when we're looking at the interference. So the jet beamforming, if I just look at a standard, common base station on a 90-degree sector with a passive antenna, right, if I'm listening on that 90-degree sector, I'm going to have interference coming in at an angle, and you could see I'm seeing a minus 70 on my noise floor, which is really my interference, versus a minus 60 on my signal. So I'm getting between 5 and 10 dB of signal to noise ratio. If I have that interference rejection because I have a narrow beam pattern and I'm really only looking at that 8 degrees for that, around that subscriber, I'm rejecting all the rest of the interference. I could see potentially up to 20 dB of a lower noise floor in a busy environment, in a noisy environment over my signal. And that makes a world of difference in my signal to noise ratio. Also on our second generation antenna, right, where we have the forming, we have the side lobes are a lot tighter, and also the backscatter is significantly reduced. So if we look at our F1, F2 frequency reuse, the radio that's 180 degrees opposed to me, I can use the exact same center frequency and I'm not self-interfering. And as it connects through, plus my beam forming is 8 degrees, so I have a very narrow beam. So it's really more of a multi-point to point radio than a point to multi-point, but it's considered a point to multi-point radio. And what's great about that beam forming, right? It's a narrow beam width over the 90-degree sector, and it'll do transmit in two modes. It's going to have a beam forming when it's talking specifically to the subscriber, but it also has a 90-degree capability to put out the beacon, right, to do the message broadcasting across the whole sector in order to identify new subscribers and also to broadcast its own identifiers across the network. But as far as my communications with my end subscriber, that's a very narrow beam width, and that narrow beam width is only at 8-degree azimuth, and in the 5X band, only a 15-degree elevation. So it's a very tight beam that I'm putting out to concentrate that energy towards that specific subscriber. I'm going to do 13 dBm, with my antenna gain, but I'm going to meet my maximum FCC EIRP of 36 dBm. And the beamforming resolution is within a degree. So if we look at the 90-degree arc at at the end, I can have 1 degree of resolution to be able to pinpoint that subscriber within a degree for the energy that I'm sending out in that beamforming. So let's do some comparisons, because there's another multi-carrier system that's out there. That's the Cambium, the M450M, and a couple things that are difference between our Jet Duo is first and number one, it's predictable sector capacity, right? So with us on that 90-degree sector, both of my carriers are able to speak to any subscriber physically located anywhere within that 90-degree sector. So I don't have to worry if I have a concentration of subscribers, a neighborhood with some high density of housing in one of the carriers, and I'm struggling to use a single carrier to talk to that, to talk specifically to that narrow, 20-degree swath of customers. I can cover the whole 90, no matter which carrier I'm using. The greater service reliability and congestion spectrum, and that's because how we get the increased reliability is because we're dynamically modulating and changing the bandwidth of the connection between the base station and the subscriber on a per subscriber per direction basis in order to ensure that we're maximizing the throughput. Everything is to drive throughput. We're also doing a much higher packets per second rate than you would get off of the 450, where we're at a 500 kilobit packets per second through our radio, and the aggregate off of the 450M is 120K. So it's almost 4 times as much when the capacity is there for it to pass that data. Additionally is that we have frequency reuse, which is, it's actually really significant, because in a congested environment where you're doing your planning and deployment, it actually allows you to do a higher density deployment of base stations and with using frequency reuse in order to service the best signal to noise ratio to customers. So I can get my more radios in the sector because I can reuse frequencies, and then that reserves my adjacent sectors for different frequencies. I'm not using all of them on the same pole. Much easier install, right? It's half a size, a third of the weight, right? So I still have you could literally clip a Jet Duo to your belt as if you're a tower climber and climb with a Jet Duo on your belt. Additionally, it has the built-in GPS so that it can synchronize timing. And so as soon as you take it outside and plug it in, it can do GPS acquisition. Our new MultiSector. This is going to be a very advantageous radio for very specific markets, right? Where we're wanting to get, out and get customers connected. And, a lot of cases, big case for it is going to be rural environments where there's a low density of customers. And so the cost, average return on unit for the cost to deploy out, a solution to reach these people that are separated. This is going to lower that cost and get you to be able to get these people connected. It's our point to multipoint, so it's all of the same interior functionality of the Jet Duo. Has the 1.5 gigabits internal dual carrier, right? The internal modulation techniques and everything, all of the proprietary modulation techniques and functions from Radwin are all in that base station, so it's a fully functioning base station. But out of the box, it comes out and it's a 180-degree sector radio. The external antenna option for it, if you just buy the external antenna to go with it, which is also that much, lower cost because it's just an antenna, you can then cable directly from this base station that's already pre-connectorized to connect to it, and you can create a 3 gig, 360-degree modular deployment. So now instead of putting up 4 radios, 4 90-degree radios, I can buy 1 radio and an add-on antenna and create a 360-degree deployment. The radio for it, as putting out for some of the functionality is that because it's a you're connectorizing, it's an N-type connector. There isn't beamforming technology in it, but as far as running a sector radio, low-cost sector radio, in order to connect a group of clustered customers, it's going to have great functionality for that. It also has the integrated switch in it for connectivity across the network for setting up multiple VLANs and the like, and internal GPS, just like our regular Jet Duo. And then they're adding in what's called self-backhaul capabilities, where you'll be able to designate a portion of the capacity of the base station to drive another subscriber, but drive that as your uplink direction, right? So I can put a subscriber back at my where my tower is, and connect out and have my base station, my multi-sectors there. Or we could do, in some designs, is do a Jet Duo way up on a tower, have high capacity Radwin Alpha subscribers off that Jet Duo, and then use those Alpha subscribers to drive right into a multi-sector to aggregate that the number of houses in that specific area at a lower cost than having to deploy specific resources from a faraway tower and have individual subscribers, which is what we're doing in very rural environments now. And it still is the full Duo. So I'm really excited to play with it. We have the, just give me the idea, it's like where it is for driving that cost, right? If we come out of the box with just the unit out of the box, it's 1.5 gigabits and it's 290-degree sectors, right? So you got 180 degrees of coverage off of the unit. If I add the second antenna, I'm now at list price $2,100, and the setting up with just a passive antenna. So I got 1.5 gigabits of capacity for $2,100. But if I wanted to get some more capacity, instead of using the passive antenna option, I could add another multi-sector radio, still use the F1 frequency reuse on the other radio on the opposing 90s for 4 times 90-degree sectors. And so now I have a full 4-carrier 360-degree deployment out in the field. And you could also use third-party antennas. That was another nice, is where I have, hey, I can get some people on the 180, but on this, I need to have a customer that's farther out or wants higher capacity. You can use the additional antenna ports that are on there to drive a third-party antenna to service that end customer subscriber. Looking at our Jet subscriber units, the good old IP66 embedded unit is still there. It has the embedded with the turbo gain, but if you're selling new, we also, that's what the driver is that why we designed the integrated, we call it the Alpha integrated, same thing. It's a 22 dBi, but by enclosing it completely and then putting a watertight connector on the compression connector on the bottom, we got it up to an IP67 rating. So it's a good 22 dBi integrated IP67 subscriber, and you can purchase it in capacity license. So if I get the Pro, I can buy if 50, 100, 250, and 500. But you can buy any a lot of 100. But if I occasionally need a 250 for a customer business or a 500, I can still keep my stock of 100s and then go up to 250s and 500s for with just a license key that's a purchase license key. The Air SU subscriber Air comes in a 100 and a 250 meg flavor. What it'll do is the difference between the Pro and the Air. The key factor is that the Pro will allow you to do a service level agreement, where I can set the amount of data that I'm providing to an end customer. I can guarantee them that data. So if it's a 50 meg, I can do a 50 meg SLA. It requires a Pro base station, but I can supply them with a guaranteed 50 meg. If they're using that 50 meg, then they'll get guaranteed uses. But if they don't use it, and they're still guaranteed, we'll still provide that to them, but we can scavenge that back. But if they're using that and all of a sudden the conditions worsen outside, the weather conditions, it will actually compress the best effort clients and still guarantee them that throughput on the Pro. It runs all of the IC35 and the 4.9 to 5.9 FCC bands. It'll do 20, 40, 80 megahertz dynamic bandwidth. We have the integrated for we call the alpha or embedded and turbo gain. The reason for still using the embedded is you have SMA connectors, so you could either use the turbo gain on it or use that radio in case you were going to use a third party, like an RF Elements antenna for some kind of a special installation. And then on the modulation, max modulation is our QAM 256. And we have our WinTouch downloadable from the Apple and Google stores to it's a smartphone application that once you're registered, it's a really nice application for ease of installation. You can almost get to the point of having a non-technical person perform the installation of the radio. I want to talk about the IDU-S. This is our new switch. Everything that was missing in the IDU-H is in the IDU-S. So if we go, starting off, it's dual DC inputs, right? We're doing a lot of solar plants on remote sites, and also now for remote sleds, and also in telecom facilities. You have the DC rack power, so we could do dual DC inputs. And the reason why it's a dual DC input is that I can use just like any other component in a vertical rack, I can power the DC from the previous line in the rack, and then continue the DC feed up to the next device in the rack itself without having to run extra pairs of wire. It's a full layer 2 switch, right? Multiple VLAN capabilities. It's going to do spanning tree protocol, and which gives us some great advantages that I will talk about. It is a fully managed Ethernet switch, so you can log into it. It's fully managed. It's also integrated. You can integrate the IDU-S into our into the WinManage platform for monitoring all of the ports and controls with it. And so we have on the face of it, you have the 6 PoE ports, and all of those ports can do 90 watts per port, right? So this thing's a small package, but it's a real powerhouse. And you could use that to drive the high power. And the reason we need that 90 watts is to drive our duos. There's also some high power cameras now and things like that that people are deploying that are coming out with it. If you're going to do heater, don't power the PoE off the heater. Use the DC. And if you got off of it as well, we got the 4 1 gig SFP ports, right? So I have the 90 watt PoEs, but if I'm going to run, long runs, if this is going to be inside and it's going to be several hundred feet to go to the, outside to go to the connection, right? I can run SFP and drive that with light and not have to worry about Ethernet limitations to get out to my radios. And then also 2 1 gig by 10 gig, so I can get up to 2 10 gig uplink SFP ports, which is nice because if I'm doing fiber even on the roadside and pulling it in, I can have my 10 gig ring, and I'm dropping my 10 gig in and out of the IDU-S and moving it on to the next down the road to my next facility with the SFP. The 540 watts total budget, right? So you're gonna have plenty of power, and then we have to say too is that the 540 watts is limited by the feeding power supply, right? You got to make sure you got enough power to it because it'll drive what you need it to do. Console port for local management. It's just like even though it looks like an Ethernet, it's still that same Cisco familiar console plug-in command line interface. You can log in. I could do SSH command line interface or the full web GUI. To configure it, the web GUI is getting to that, the Radwin common view interface that we're seeing. So, on our GUIs, they're really working hard to make the familiar remain, how the menus are laid out and from device to device. And they've done a really good job with the IDU-S. and it also comes with 19-inch rack mounting hardware to extend it. So some of the switching capabilities in the IDU, it'll do MAC address entry, 16,000 entries. The backplane, the switching backplane is the 68 gigabit backplane, so it's going to be able to move a lot of traffic across it. The forwarding rate is 58 million packets per second, and now we can do frame sizes of 9,600 bytes, right? So nice, big jumbo frames will go through. Layer 2, what are we getting off of the layer 2? Auto negotiation for it from both the SFPs and the Ethernet ports. I can do up to 4,000 VLANs, and I can do tagging and access on any of the ports. So now we can do separating groups, because now especially for smart cities, we're doing different VLANs for the security of the police network, and the parking department is another VLAN. You can manage all of that right on the IDU-S. And then the big thing too is that the 802.3 LACP link aggregation is awesome, because now if I'm adding capacity and I'm put up a D2000 point to point as my backhaul from a sector, and I'm adding more customers and I'm starting to strain my backbone. If I add the IDU-S, I can put that in. I can add up another second point-to-point link off of that, and then aggregate over those two links. Also, if I'm doing a deployment for heavy camera or something like for a municipality, and I need a heavier backbone, now I can aggregate two point-to-point links over that backhaul, doubling that capacity of the point-to-point, and still not having to go to a licensed radio, right? So you can still save money by aggregating up all those links. IGMP snooping for it, version 1, 2, and 3, great because a lot of people are still doing, they're still broadcast video, so we want to be able to do IGMP snooping. Broadcast storm control, that's the key there, the full spanning tree protocol. So we're going to limit the broadcast and multicast across the network to minimize storm control, also to prevent any kind of a broadcast denial of service attack on the system. Full spanning tree protocol. We're going to implement the 802.1d W and S for whatever the deployments are. It's very compatible with any kind of a Cisco environment or Calix environment in order to integrate directly in. And then 802.3 X full, right, and back pressure. Next thing I want to talk about is our life cycle. That's our OSS. That's our life cycle management suite, right? And so what we want to do is that the first thing that we want to do is, hey, I want to get into I got a crazy idea. I'm going to get into the fixed wireless network business, right? So the first thing I need to do is plan my network, right? We have our planner tool, and we're developing. They're actually, rebuilding the R planner from the ground up, taking all of the best features that they have in it, keeping them, and then adding in everybody's wish list that we've been asking for the last couple of years, right? So it's a cloud-based application. Right, so you don't need to have a significant local resource in order for it to run, right? And you could do your coverage and frequency planning, so it'll give you a coverage deployment. Right now, the platform does just a geographic and free airspace design, but it will let you know if the geography, right? If I can't shoot to the other side of the mountain, but we're going to be adding in clutter data in Q3 for the R planner. So now I'll be able to plan if there's trees or buildings in the way in my shot. I'll be able to account for that for my coverage. It's going to be really nice for doing our network sizing. If I need to add additional links, what's my capacity? It's going to give me my analytics about how much of my sector capacity am I utilizing on my backbone links, and do I need to add additional capacity if I'm adding in new subscribers or new base stations. And then also based on that, you'll be able to get your service availability estimations. And depending on your environment anywhere in the world, you'll be able to plug that in and get a decent availability estimation, right? I'm going to plan out to 4 nines of availability, but maybe 2 nines is sufficient. Once we have our network planned and agreed, and we're actually going to go out and we're going to build it, all right, we're going to do our Win deploy. It's our deployment tool. All right, it's like I'm going to go out, build my network, and then I'm going to put in the location of my base stations and their azimuths and where they're at, and that'll feed over from planning to actual. So it's like an as-build, right? So my as-build's going to be there, and it's going to be a cloud-based. But what's nice about it is that I'll be able to go in and have a person, be able to answer the phone who's not technical, type in an address of a potential subscriber, and the system will tell them immediately whether they're within the service capability of one of the towers, one of the sectors, and what service capability that they'll be able to get, right? What can I sell you, a 25 meg or a 50 meg service, right? And then also give the alternatives. If that person then says, okay, it looks green, right, that person can create a work order. So this is a completely non-technical person who can take that initial call, do a quick initial evaluation of the possibility of this customer being able to come up on the network, and then creating a work order for somebody to go do an analysis on to say, yeah, let's, this is doable. Let's go and get a installer out there to go and see, get that service turned up. Once that work order is done, then they can, in the Win deploy, you can actually create the work order. That work order can then be assigned to a technician, and off to sign the technician, and it'll show up on their WinTouch as a project as their job. So you can see their job in the WinTouch. Once they're out, they go and do the job. They use the WinTouch. It's really a simplified site installation. I have a video that running through it, which I'll share afterwards. But you get your work order, shows you how to set your frequencies, already pre-populate some information for you, some key information. They get up there, you do the alignment, lock it down, take photographs. It'll do a service qualification test, so it shows me what my throughput is. This is even before it's been turned up. All before it's been turned up, I can do the verification. I save that report, and then I send it in, and it goes back to my deployment manager, and then you can review that and store that installation. So I have all my installation information, and I have good records, right? Now I have good records of that installation, and the customer's turned up. Now the customer's turned up. What's the next thing it does is that we need to manage it, right? So I can have my Win managed network has configured to go out and continually automatically discover new subscribers on the network, so even doesn't need human intervention. It'll go out and find everybody you turned up, add them in and start monitoring it, monitor for alarms and conditions. All of it is highly customizable. We put a lot of thought into that Win managed system. All right, so you have good visual displays and pop-up lists and reports and alarming and configuration, but we've set that all up so it's out of the box. You can just start using it, but you're not locked in, right? Like some other providers, it's like the cloud-based environment, and you have to manage the way that the system is designed to tell you how to manage. We don't do that. You can create your own views of the network. You can do own reporting. You can do your own analysis. You can do your own automated process reportings on there. It's really a neat interface, and all to manage your network. And then also, if you from the NOC, if you see something that needs to be done, because it's an NMS, it's a network management layer, you'll be able to right-click, cut through, and then cut either right to the GUI HTTP session of the EMS right into the radio to manage the radio, or if you're still using the Radwin Manager, you can launch the Radwin Manager and connect via proxy, and all of that's protected, right? So you don't have to have everybody be able to get to the core. It's all by proxy and protected, and the only thing that you're exposing is port 443 HTTPS or external VPN if you're VPNing in. So it's very secure as well for managing your network. So a new feature that we're adding as far as professional services, right? So in dealing with professional services, we're always trying to help and get networks up, but we're offering a wireless network audit and optimization service, right? and this service that's out there. So why did we think about start doing this? Is that if we look at is that this is the new normal, right? So with COVID, what this is representative of, it's a single base station on one of the networks, one of our customer networks. The daily average bytes for the first 15 days in January versus the first 15 days in May. And so you saw, without it adding any additional subscribers, that's where I went and found one, what was just a change in the network since the, what was the change in the network since COVID? We know people are staying home. And you could see, we averaged it out, it showed a 265% increase in the demand on the existing network. So, hanging more radios in a lot of cases wasn't an environment. So what we said was, hey, let's go do an audit, go out and audit some networks. We can provide it as a service. We can use that audit to go out and identify some poor performing subscribers on your network sector for it. This could be your whole network, specific sectors or whatever. Find those subscribers and then offer you suggestions on how you can make improvements, right? We can then, as an alternative, once we get the audit, we can give you an audit and identify where your weaknesses are. You can actually also engage the professional services team to act upon it. We can help you to come in, correct issues on the network, help to retrain if you're having installation issues. Go out and work with your team in order to, or the end user's team to go out and improve the poorly handled subscribers, and identify other stuff, and also to give you how to do better load sharing, balance, better frequency assignment, addition of additional capacity, to help you improve your overall network. One of the things to think about, right? Not just fixed wireless access is what we're really known, but other things that we can deal with is smart cities, right? Going after the getting video surveillance and shot spotters and biological detectors connected. We're really good at that with the jet, opportunity. Doing seaports, right? We're doing a lot of seaport automation. There's a lot of stuff in oil and gas and mine. We call that strategic industry where our products fit. So it's a pretty comprehensive solution that we have to deal with throughout the network, and also, we're utility grade connectivity, and really for that micropop, the multi-sector and multi-tenant fixed access, that's going to be a really nice radio. It's a really nice feature to have because it really is cost effective to get people connected. And with that, I'm going to let Sheila jump on and talk about some opportunities to sell.
All right, so thanks so much, everybody. I can see that most of you have hung in there with us, and I think the presentation that David gave was just chock full of really good information about how Radwin implements different technologies, platforms, and then also providing services to help you optimize your network when you are utilizing our equipment. We recently announced a new promotion. It's effective from July 1st through September 30th. And this allows you to generate and win new accounts. So if you're an end user on the line, this is for you. If you're a partner on the line, you can advertise this to your customers. For either the Jet Air 500 or the Jet Duo 5 gig radio, you can buy one and get one free. And the cool thing is you can purchase up to 5 units of either or each of those products and receive up to 5 of each of them for free. So this is a great opportunity to go after accounts. Now, when I say a new account, the definition is not having purchased Radwin during 2019 or 2020. So you have an opportunity to also go back to accounts that may have installed some Radwin back in the day. Let's say 2018 seems like a millennium ago, and maybe they need to add some subscribers. Maybe they need to augment their towers with the additional base stations, add towers, etc. This is a perfect opportunity. So I wanted to highlight that for you. The slide just before the promos that David was going over, which kind of shows the ecosystem, if you will, of all the different types of applications and installations that we work on. I did provide that as a handout. The screen you're looking at now is simply the first page. It's 4 pages long. It does list out the products and part numbers for you. It does give you some key kind of benefit statements and also information on those operational support systems tools, the OSS tools that David spent a good amount of time helping you understand. So with that, there is a link and landing page for the promotion. I've asked Winncom to post that for you, but obviously the Winncom sales team is ready, willing and able to give you the information on the promotion. But you're also you're invited to reach out to me directly if you'd like that link or more information. And my email address is Sheila_K@Radwin. My first name is SHEILA_K@Radwin.com. So with that, David, I'm going to turn it back over to you.
Thank you, Sheila. All right, so at that point, we are at questions. Anybody have any questions in the last few minutes that we have? On the